Hello, today I'm going to show you how to calculate the integral of tangent 5x dx. Okay, this integral you can write it as tangent x times tangent 4x dx. Okay, from trigonometry we know that the tangent s squared x is equal to secant squared x minus 1. Okay, this formula you should know that. So if I substitute this equation into this integral, you can rewrite this integral as integral of tangent x times, instead of tangent 4x, I write secant square x minus 1, which is equal to tangent square x with the power of 2, okay, dx. Okay, so now I'm going to expand this expression. From algebra, we know that a minus b with the power of 2 is equal to a2 minus 2ab plus b2. Okay, so in this case, a is equal to secant x and b is equal to minus 1. B is equal to 1, sorry. Okay, so now, therefore, you can rewrite this integral as integral of tangent x times, that is a, that is b, so that will be a2, that is secant 4x minus 2ab, 2 times 1 times secant square x plus b2, which will be 1 dx. Okay, so now you can expand this integral into, that is equal to integral of tangent x times secant 4x dx minus 2 integral of tangent x times secant square x dx plus tangent x times 1 is equal to tangent x dx. Okay, so here all I did, this term multiplied by that dx, this term multiplied by this dx, and this term multiplied by 1 dx. Okay, so this one now, I can rewrite this integral as integral of tangent x times, instead of secant 4x, I write secant square x times secant square x dx minus 2 times tangent x secant square x dx plus integral of tangent x. So that will be integral of tangent x dx. Okay, so this integral now, you can solve it by substitution rule. Okay, so here, if you define u as tangent x, okay, and if you take the derivative from each side of this equation, du will be equal to secant square x dx, okay, because derivative of tangent x is secant square x dx. Okay, so now if I substitute these two equations into this integral, you can rewrite this integral as integral of, instead of tangent x, I write u, okay, instead of secant square x, you see here, secant square x is basically equal to 1 plus tangent square x, and since tangent x is u, therefore secant square x will be equal to 1 plus u2. Okay, so that is u, that is 1 plus u2. Instead of secant square x dx, you see here secant square x dx, I simply write du minus 2 times, instead of tangent x, I write u, instead of secant square x dx, secant square x dx, I simply write du, okay, plus instead of tangent, the integral of tangent x, so we know it from table of integral, that integral is equal to ln secant x plus c, which is the constant of the integral. Okay, I had actually solved this integral of tangent x dx in my channel, so if you're not sure how to calculate this integral of tangent x, just look into the corresponding videos and you will learn how to do that. So now this integral is relatively straightforward to calculate. That will be equal to so integral of u times 1 du, okay, that will be u du, okay, plus integral of u times u2 du, that will u 3 du, minus 2 integral of u du plus ln secant x plus c. Okay, and so here you have integral of u du minus 2 integral of u du, so that will be basically minus integral of u du plus integral of u3 du plus ln secant x plus c. So an integral of that will integral of u du is equal to u2 divided by 2 plus integral of u3 is u4 divided by 4 plus ln secant x plus c. So here all you need to do is just to substitute parameter u with the definition of u, which is tangent x. Okay, so therefore this integral now will be equal to, instead of u, I write tangent x with the power of 2 divided by 2 plus tangent 4x divided by 4 plus ln second x plus c, which is the constant of the integral. And that is the solution to our integral. Okay, I hope you found this video helpful. If you are interested, please feel free to subscribe to this channel so that you get updated when I upload new videos. Thank you.